All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up number 57 is on the screen. And once again, it's the same warm-up that we've been working on all week. I just changed the values to see how you do with that. For number 1, it's simplify, and they give us square root of 60. Number 2, they want us to transform the parent function f of x equals x cubed. And they give us, for parameters, a equals 1, b equals 1, h equals 3, and k equals -4. For number 3, it says solve by completing the square, and they give us the equation x squared minus 8x minus 20 equals y. And the last one has a circuit, same circuit that we've been using all week. The current 24 plus 12i, and they want us to find the voltage for the resistor. So make sure you copy, and those that are watching online, those that are with me here, you should have gotten the Cornell note from over there. And on the Cornell note, you should have the warm-up already there. You don't need to create anything, yes? All right? Let's get started. Copy and... All right, here we go. Number 1. What'd you get for number 1? Christian, go. Approximately what? Very good. Who got 7.7? Approximately 10.7? Okay, good. Yes? How are you doing? Thank you, sir. Excuse me, sir? Yeah, she's not here. All right, thank you. All right, number 2. We have a cubic function. Here it is. Look at it. What would be my vertex for this one? No, the original one. 0, 0. Okay. So now with this transformation, we get g of x equals f of x minus 3 cubed minus 4. So my new vertex would be what? Tell your neighbor. Our new vertex for that transformation. Yeah, I heard 3, -4. So that means we would move this one to 3 to the right, 4 down. So it would be somewhere down here. And that would be my g of x. Hands if you got something like that. Okay. Number 3. We should get x equals something, x equals something. What'd you get for that one, Philip?
I got x equals 10, x equals -2.
10 and -2. Hands if you got that. That is correct, and you did that by completing the square, right? Not just doing the factoring or anything, right? Okay, good. And number 4, what is the voltage going through those resistors? Voltage going through those resistors, Carlos.
Voltage 96, voltage equals 96 plus 48.
That is correct. Hands, have you got that? Yes, because the resistors are what? 1 ohm plus 3 ohms, that's 4 ohms, and you just write it as a regular real number. So you need to distribute that into this, and that's how you get the voltage. All right? Copy the agenda. You have, on the Cornell note I gave you a space right underneath the warm-up. You can write that in there. Hopefully it fits. Warm-up number 57, the circle. And our home plate pages is 165, 166 only. And reminder, today, tutoring after school. Be there or be elsewhere. And by the way, it's free. Oh yeah, I'm telling you. All right. So, Nearpod code, you need this for the pages in case you don't have the text. Those of you watching online, you may also get this code S4JG8. S4JG8. Just go to Nearpod, type that in. It's going to ask you for your name, and then you go to the slide where it says home plate, and it should give you the PDF pages there, yeah? All right. Next, that was the previous home plate, and once again, our home plate for tonight, 165, 166. Let's get started, yeah? Here we go. We got a lot to cover, so everybody go like this. Bear with me, yes, here we go. So, write the objective at the bottom left, and it reads, I can write and graph the standard form equation of a circle. I can write and graph the standard form equation of a circle. I can write and graph the standard form equation of a circle. I can write and graph the standard form equation of a circle. So, what are we doing? We're writing and graphing, yes. What are we writing and graphing? The standard form equation of what? What's our main concept for today? Circle. So to save time, I gave you the Freyer model and the Cornell note. Those of you that are watching online, I'm going to post that right now on the screen. All right, so here we go. Circle. Now, we've been covering circles since elementary. We know what they are, but today we're just going to be a little bit more specific, and we're going to address it in from the perspective of algebra. Okay, here he goes. So what is a circle? A circle is the set of all points in a plane that are equidistant from a given point called the center of the circle. Now you have that on your Cornell note. Those of you that are watching online, you can copy that. However, I want you to underline the word equidistant. Underline the word equidistant. Now that's a self-defining word, if you want to call it. It's a compound word. Tell your neighbor what that means. Equidistant. Equidistant. Brianna, what do you think it means? Help her out, Brisa. Equal distance, yes. Equidistant, equal distance, same distance. All right, so if I was to sketch a circle, look up, like so, here it is. That means that has an infinite amount of points that are what? The same distance from where? From the center. So draw that, please. The center in red, because we're going to be using the same colors. All these points now became a circle. Another word for circle that we use, that we've been using since elementary, it's known as what? Circumference. You guys remember that? Yes? Bless you. So, the center. So once again, all these infinite points are the same distance away from the center. Now that distance from the center to all those points has a name. Everyone? Yeah, very good. The radius. So draw your radius in blue. We're going to need that as well. The distance from the center to any of those given points around that are equidistant from the center is known as the radius. And just to label the last part of our circle, we're not going to be using it as much, but just to label it, there's another distance from one side of the circle to the other side of the circle that passes through the center that is called diameter. That is correct. So label that in black. So, once again, today we're going to focus on the center and the radius. Okay? Any questions with what a circle is? No, according to the definition, it says that all these infinite amount of points are equal distant away from what? From the center. Okay? So tell your neighbor a non-example and write it in there, or draw it in there, whatever you want to do. All right, Rachel, go. Non-example. A what? I couldn't hear. Rectangle? Okay, a rectangle. Lois, another example. Bless you. What is it? Rhombus, okay. All right. Carlos? A what? Umbrella. An umbrella, okay. All right, good. Write that in there, please. So, What makes a circle a circle? What would you hashtag this picture if you were to send it in your social media? Hashtag what? 360, okay, 360. What else? Equidistant, yeah. Equidistant. How about equidistant from center? Okay. Yeah. You got it, yes? All right. So, turn your paper over, copy this down. So now that we know what a circle is, let's find out what a standard form equation of a circle is. Write this down. Standard form of the equation of a circle is parentheses x minus h squared plus y minus k squared equals to r squared. X minus h squared plus y minus k squared equals r squared. Now, hopefully this is triggering something in your noodle. Something squared plus something squared equals something squared. Something squared plus something squared equals something squared. Tell your neighbor what it's reminding you of. Noor, what's it reminding you of? Yeah, a squared plus b squared equals c squared, which is the Pythagorean theorem. Yes, that's pretty much what we're looking at, because we're looking at a distance from the center to the circle, right? All right. However, look up again. Look at the that form. There's something familiar in that form that we've been using already for a long time. Talk about your neighbor. What have we been using for a long time? All right. What have we been using for a long time, Brooke? The x minus h, yes. Y minus k, not necessarily, but h so far, yes. What else? K. What do we call those two together? What have we been calling them? Yeah, they're parameters, but together they are the vertex, yes? But today they're no longer the vertex because now it's a circle, so it's known as the center. That is correct. You're like, oh, Mr. Q, kind of sneaky there. I know, I'm telling you. I've been prepping your noodle for a fat minute ago. And tell your neighbor what R stands for? Very good. Rotation? No, the radius. Oh my goodness. I should have written rhombus or something. I said it, rhombus? No. Alright, so any questions about what we're looking at? H and K are my center, and the radius is the radius. Now, before I move on, though, look up. If I was to ask you, what direction will K move the circle to, you would tell your neighbor it would move it in which direction. Talk about your neighbor. In which direction? Everyone? Up or down. That is correct, which means H would move it where? Side to side. We got this, yes? Okay? Now notice I have not included A or B yet. Okay, we good? Alright. So, shall we? Here we go. Example 1. Copy this. It says, write the equation of the circle with center C at -3, 2, and the radius 4. Just copy it, and I'll go over that one first. I'll give you some time. Copy that in. Alright, here we go. Writing utensils down. Look up to the screen. So we're starting slow. Okay, here it goes. And it says, y'all ready? Okay, here it goes. It says, write the equation of the circle. Well, what do we know? What kind of equation? Standard form, right? So watch. Don't write this down, just pay attention. I got x minus h squared y minus k squared equals to r squared. Are we there so far? Okay. What information do they give us? They give us the center. We know that this is what? H and K. And we know that this is our what? Radius, which is the r. So watch. I'm going to rewrite this, x minus y minus blank squared. Okay, so I'm going to start with h. What is h? Negative 3. What is k? 2. What is r? 4. And then I just simplify, so this is x plus 3 squared, because negative times a negative is a positive, plus y minus 2 squared equals 16. This is our standard form equation. Copy that, please. All right. From 1 to 5, how can people argue with these? Yeah, piece of cake. It's just substituting values, and we're good. Okay, let me give you another one for you to do by yourself. Once again, we start with a standard form. We end up with a standard form, but with the values. Okay? Here you go. Example 1Q. Copy this. You don't need to copy the instructions anymore. Just copy C is at 1, negative 4. That's our center. And radius 2. Just copy those two things. And I'll give you some time to write your standard form equation of that circle. Copy and go. All right, you should be done by now, yes? For the process, here's my standard form equation. I take away the h, the k, and the r, and I use these values now to substitute in here. So instead of h, it's 1. Instead of k, it's negative 4. And instead of r, I'm going to use 2. So if I simplify, this becomes x minus 1 squared plus y plus 4 squared equals 4. And this is my standard form. Hands, have you got that? Okay, we got it. Yeah? From 1 to 5, how comfortable are you feeling? Yeah. 5s, right? Here goes the next one. Don't copy this. Writing utensils down, look up to the screen. Center, 8, 9. Radius, 10. If I was to ask you to think about the equation in standard form, tell your neighbor the equation, please. All right. We got it, yes? All right. So let's see, what's our equation? Yeah, Lexi. Oh, minus 9, not bad. Minus 9. 100. Hands, have you got that? All right. We good, yeah? Okay, copy this next one. Example 1 mega cube. The center is at negative 3, 0, and the radius 6. Copy that and write me our standard form equation simplified. Ready, go. All right, let's see. Walk me through this process. Miguel. So I got x minus h squared plus y minus k squared equals to r squared. And of course, the next step, you just write that without the h, that without the k, and without the r. So tell me what to substitute and go from there. Negative 3 for h, yes. 0 for the k, so I got h and k, okay, and then? And 6, all right. So what do I write now? X plus 3 squared. Okay. So think about that. Do we need to write the 0? No, so what would I write? Y squared, that is correct. Equals to 36. So whenever you get an equation that looks like this, don't think that it looks weird. You're like, Mr. Q, it's missing a parenthesis. So if it's missing the parentheses, Is it going to move on K? Is there any up and down movement? No, because there's no K. It's only moving what? Side to side, okay? From 1 to 5, how come do you feel with these? Yes? 5, 5, 5, 5, 5, okay? Crank it up a little bit, yeah? All right, copy this. Example 2. Center, -4, -3, containing the point 2, 5. So write the center, and then point 2, 5. Center and point 2, 5. Copy that. All right, here we go. Writing utensils down, look up to the screen. I'm going to talk through this, and then I'll have you copy right after. So on the previous examples, we had a center and we had a radius. Do they give us a radius? No, that means I need a radius to write my equation. So let me label what they give us. They give us h and k, but instead of the radius, they give us what? A point, which is what? X and y. So watch, look what I do. I start with my equation again. Then I rewrite this with a minus in there, and you're just paying attention. R squared, because that's what we're looking for, yes? It's an ugly parentheses. Okay, there it is. All right, now let me substitute values. H is -4. K is -3. What is X? 2. What is Y? 5. Now watch. What is negative times a negative? This becomes a positive. So what is 2 plus 4? That's 6 squared. Negative times a negative is a positive. That becomes what? 8 squared equals, oh my goodness, equals R squared. Copy that, please, and we'll finish it together. All right. All right, help me out, solve. What is 6 squared? Plus equals R squared, yes. 36 plus 64, everyone? 100 equals R squared. And how do we solve for R? Square root, so that gives us 10 equals R. Do we have our R now? Yeah. Do we know what to do with this information now to write our equation? Yes. So we write our standard form again. X minus h squared plus y minus k squared equals R squared. X minus y minus squared over here. So my R is 10. My h is -4. My k is -3. So if I simplify this, this is x plus 4 squared plus y plus 3 squared equals 100. From 1 to 5, how comfortable do you feel with these? Yeah, 5, 5, 5. All we need to do is substitute values, get our R, and then write our equation. All right? So I'm going to give you one to do by yourself. Hopefully you can do the whole thing by yourself. That looks like this. So far I've given you some that have the center and the radius. Now center and a point without the radius. Okay? Here we go. Example 2Q. Copy this. Center -2, 5. And point given -2, -1. Copy that and go. Alright, let's see. So, hopefully you wrote your standard form. You wrote it again without x and h, y and k, just with an r squared because we need to solve for r. So here we go. Our h and our k, we got -2 and 5. Our x and our y is -2 and -1. Yes? Okay, so let's see. What is negative times a negative right here? This becomes a positive. So what is negative 2 plus 2?
0.
0. They cancel, yes? Negative 1 and negative 5, that's negative 6 squared. That is 36 equals, let me write it out so that you guys can see it. Negative 6 squared, negative 6 squared equals r squared. That's 36 equals r squared. So, to solve for r, we take the square root, so 6 equals r. So now that we have r equals 6, do we know how to write our equation? Yes. X minus h squared plus y minus k squared equals r squared. X minus y minus blank. So this is the 6 goes there. Negative 2 and 5. Therefore, x plus 2 squared plus y minus 5 squared equals 36. Hands if you got that. From 1 to 5, how come you feel with these now? Okay. So far, so good. We've done 2 different examples. That's going to be the home plate so far. But let's crank it up, right? Make it like, let's blow it up. Ready? So let's go to the next sheet where you have the graphing portion of it. And write this down. It should read on the instructions. Write the equation of the circle, then graph. Yes? Everybody has that sheet? Yes? Okay. And the equation given, x squared plus y squared minus 10x plus 6y plus 30 equals 0. Copy that. And I'm going to zoom in to this portion just so that I can focus on the equation. So before we get started with the graph, I need to write an equation in standard form given this equation. Okay? So, y'all ready? Okay, writing utensils down, look up to the screen. So I'm going to be talking through this, and I'm going to trigger something in your noodle because we've been practicing this already. Okay, here it goes. Look up to the screen. Watch.
Opening brightness.
Notice that it has an x squared here, and it's equal to 0. Okay, look what I'm going to do. My first step. I'm going to divide the entire equation by 1. So I get x squared plus y squared minus 10x plus 6y plus 30 equal to 0. So now your noodle's already in automatic pilot. Yes? That means my next step is what, Adrena? Subtract 30 to both sides. Yes, subtract 30 to both sides, and you're just paying attention. Hold on. So on this side I get negative 30. Yes? Now check this out. This side, I'm going to group like variables. So I have x squared minus 10x. I'm going to leave an empty space. Plus, then I got y squared and 6y. And I'm going to leave an empty space. Before you copy, I'll do one more step before you copy. Look up. Your brain wants to do something here. Tell your neighbor what it should do here. Yeah? All right, so what shall we do here, Saul? Over 2 squared, yeah, and whatever we do to one side of the equation, we do to the other, negative 10 over 2 squared. How about here, Sky? Yeah, 6 over 2 squared, whatever we do to one side, we do to the other. And then we end up with x squared minus 10x plus 25 plus, parentheses, y squared plus 6y plus 9. equals to negative 30 plus 25 plus 9. Copy that up to right now, and then we'll catch up with the next steps. All right. So far, so good, yes? All right, can I combine stuff on the right side?
Yeah.
Yes, Mr. Q. Over here I can get, what is 25 plus 9? 34 minus 30, that gives us positive 4. Okay. Bring everything else down, x squared minus 10x plus 25 plus y squared plus 6y plus 9. Okay. So your brain still wants to keep going, yeah? So, how would I factor this one right here? Square root of the first, square root of the last, sine of the middle, squared. Plus, how would I factor this one? Square root of the first, square root of the last, sine of the middle, squared, and that is equal to 4, and this is our standard form. Let's go, let's go. What a beauty, right? All right. From 1 to 5, how comfortable are you with these? Yeah? We've been practicing a lot. What is the process that we just used, everyone? Yes, put a little asterisk. Heart, complete square. Yes, we're using that process for this. That's what we practice, yes? Okay. However, we just wrote the equation. What are they asking us to do as well? Graph. To graph an equation, a circle, we need this. Watch. We need the center of the circle, and we need a radius. Look at this equation. Talk it over to your neighbor, let them know what the center would be of this equation. What would be the center of that circle? Alright, center of that circle. Let's see. Bree, what do you think? Close. The negative is part of the form, is that correct?
Oh, 5.
So it's 5. Negative 3, yes, because remember the negative should be part of the form, right? All right. Now here goes a tricky one. Somebody that forgot. What is the radius? Talk it over with your neighbor. What is the radius? See if they agree with you. I see some of you that do see it. Some of you are like, wait a minute. Okay. Who said 2? Yes, that is correct, because remember we get this number over here by doing radius squared, is that correct? So to get the radius, then we do what? 4 and take the square root of 4. That's how we get 2. You all ready to graph? Yes, very simple. This is going to be so simple you're going to be like, what? Watch. We're going to use a definition. Ready? Let's plot our center first. What is our center? 5, negative 3. So we go to 5, negative 3. According to the definition, a circle is formed by what? Tell your neighbor. By points that are what? Equidistant. Do we know that distance? Which is what? 2. So we're going to plot points 2 steps away, all directions. Yes? 1, 2. 1, 2, 1, 2, 1, 2. Does that make sense?
Yeah.
Right? Thinking about it using the definition, now you're like, no wonder we had to really think about the definition. Yeah, because it makes sense now with a graph. So, I hope the approach made sense. I'm going to give you another problem so that we can work it out together, just to make sure we got this process down. Okay? So, they gave us an equation. They wanted us to write an equation in standard form. What did we do? We used what process? Completing the square. We divided by the leading coefficient, eliminated the constants, completed the square for both of these once we grouped them by like variables. We simplified one side, factored the other side, and that's how we got our standard form equation. We wrote our center using that equation, and we wrote our radius from there. To graph, we plotted our center, and then the radius is the same distance all the way around. We plotted those points, and there's our circle. All right? Example 3, that's too easy. Copy this one, mega cube. We got 3x squared plus 3y squared plus 6x plus 12y plus 3 equal to 0. I'll give you a head start, copy that and go. Alright, let's see, get us started. Miguel, what do I do first? Oh my goodness, sorry. Divide by what? Divide by the leading coefficient, which is 3, yes? So therefore, 3x squared divided by 3 is x squared. 3y squared divided by 3 is y squared. 6x divided by 3 is 2x. 12y divided by 3 is 4y. And 3 divided by 3 is 1, and all that equal to 0. Yeah? Some of you skipped that step, and all of a sudden you got fractions, and you went crazy all over the place. So don't skip steps, please. Next, continue. Christian, go. Yes, -1, very good. So I bring down the -1. I rewrite this, but I group like variables. So x squared plus 2x, empty space, plus y squared plus 4y, empty space. Continue. Audrina, what do I do here? 2 over 2 squared. We do that to both sides. 2 over 2 squared. And here? 4 over 2 squared to both sides. Hands if you got it to right there. Yeah? We good? Next, so we get parentheses x squared plus 2x plus 1 plus y squared plus 4y plus 4 equals to -1 plus 1 plus 4. Continue there. Can we simplify the right side? Brooke? Yes. What do we get? 4. Yes. So this is a 0 pair. I bring this down. X squared plus 2x plus 1 plus y squared plus 4y plus 4. Continue, Philip. What do I do next? Factor?
Factor, yeah.
So how do I factor?
Use Power Rangers.
Power Rangers or?
Just keep your mental way, square that, and then square the opposite.
So what do we get?
Yeah, x plus 1 squared.
X plus 1 squared. If we do the same to this, what do we get over here?
Y plus 2 squared.
Y plus 2 squared. And all that equal to 4. Hands have you got up to right there? Yeah. So our center, what's our center? Everyone. -1, -2. And our radius, everyone? 2, because we take the square root of that. So let's graph this. -1, -2. And then 2 steps in all directions. And there it is. Hands if you got that by yourself. Okay, not bad. All right, so from 1 to 5, everything that we did today, how comfortable do you feel with that? 5, 5, 5, 5. Yeah, we got this, yes? So your home play is basically all those 3 examples for home play, and I think we got it. Tomorrow is going to be a day of practice, but with word problems, okay? And I'm going to have Ms. Zamora do that tomorrow with you guys, okay? So we'll stop right there. Once again, tutoring after school, be there or be elsewhere. And I'll stop the video right now. Have a good one. Bye.